You know those massive warehouses and sprawling factories you see along the highway? Ever stop and wonder how they actually get built? Well, the way we do it is changing, and it's happening right under our noses. There's a quiet revolution going on, and we're about to dive into how we're starting to build our biggest buildings in a completely new way. So get this. What if you could just skip months of messy on-site construction? I mean, imagine, instead of building everything from scratch in the mud and the rain, we could just assemble our biggest structures like they were giant Lego sets. It sounds kind of futuristic, right? But it's actually happening right now. And it has a name. It's called a pre-engineered building, or PEB for short. The idea is actually super simple. All the main parts of a building, the columns, the beams, the supports, they're all designed on a computer and then built with incredible precision in a factory. Then they're just shipped to the site and bolted together. And that is the absolute game changer. Think about traditional construction. It's slow, everything has to happen in order, and you're totally at the mercy of the weather. But with PEBs, the whole process happens in parallel. While the crew is pouring the foundation on site, the building's entire skeleton is being perfectly made in a factory, miles away. This just completely rewrites the rulebook on how long it takes to build. So let's just walk through how it works. It's basically a four-step dance. First, everything, and I mean everything, is planned out in a digital model. Second, those plans go straight to a factory where robots and high-tech machines cut and shape every single piece. Third, all those building blocks get delivered to the job site. And finally, cranes just lift them into place and a crew bolts it all together. No waiting around for concrete to dry, no massive piles of waste on site. It's clean. And the result of this whole factory-first approach? Well, the entire construction process becomes 40 to 50% faster. That's not a small number. In a world where every single day costs money, that is absolutely massive. Okay, so if this is so much better, it kind of makes you wonder, right? Why haven't we always done it this way? Well, it turns out we've just hit this perfect storm of conditions that is making PEBs explode in popularity right now. And you can see that explosion in the numbers. Let's take India as an example. The PEB market there is already worth over $2.5 billion US, and it's on track to blow past $4 billion by 2030. This isn't just a little bit of growth, it's a fundamental shift in how an entire country builds. So what's fueling this? It's really three key things all hitting at once. First, there's a huge wave of new demand for big buildings. Think EV factories, data centers, and e-commerce warehouses. Second, the people paying for these projects are demanding tighter, more predictable schedules. And third, the steel supply chains have finally gotten big and sophisticated enough to handle this kind of work at scale. So who's actually buying all these factory-made buildings? Well, a massive 55% is for big infrastructure projects, like airports and metro stations. Another 40% is for the industrial sector. The big takeaway here? This isn't some niche product. We're talking about the biggest, most important sectors of the economy going all in on this. Okay, so we get what it is and why it's growing, but how does this all work as a business? I mean, what does it actually take to be successful selling giant, building-sized Lego sets? It all starts with speed. A typical PEB project is done and dusted in just 6 to 10 months. Compare that to the years it can take to build traditionally. That quick turnaround completely changes the money side of things, especially how cash flows through the business. Because the model is so different, there are three things a company absolutely has to master to be profitable. Number one, they have to manage the crazy up and down price of steel. Number two, they have to keep that expensive factory humming along at high capacity. And number three, they need really efficient working capital. That just means keeping the cash lag between buying steel and getting paid as short as possible. And that second point, factory utilization, is probably the most important part of the whole business. These companies have huge fixed costs. Those factories are not cheap. So once those costs are covered, every new project is pure profit. The difference between running your factory at 60% capacity versus 85% isn't just a little more money, it can completely transform your entire bottom line. So who are the big dogs in this space? Well, the industry is still pretty fragmented, but there's definitely a top tier. You've got companies like Kirby India, Interarch, and Pinar Industries leading the charge with massive production capacities. These are the players really setting the standard for the whole market. But of course, it's not all easy. This revolutionary new way of building comes with its own very unique set of headaches and risks that these companies have to deal with. There are really three big hurdles. First, those wild swings in steel prices we talked about. Second, the incredibly complicated logistics of just moving these enormous parts around. And third, a shortage of skilled labor. It's not easy finding enough expert welders, machine operators, and digital designers to do this kind of precision work. Let's just dig into that steel price problem for a sec. Most of these projects are signed on fixed price contracts. So if the price of steel suddenly skyrockets after the deal is signed, well, the builder has to eat that cost. In a bad year, that can literally cut their profit margins in half. It is a huge, huge risk. And then there's the sheer physical challenge of it all. Just stop and think about this for a second. How do you actually get a 20-meter-long, multi-ton steel beam from a factory to a remote site, navigating our roads, without it getting bent, rusted, or damaged? One messed up piece can bring the entire project to a grinding halt for weeks. It's a logistical nightmare. But even with these challenges, the momentum is just undeniable. When you look at all the trends coming together, it becomes pretty clear that the future of construction, at least for these big buildings, is going to be made in a factory. You know, in the end, this is just as much a mental shift as it is a technical one. The very idea that a giant building can be assembled like a car or an airplane, instead of being painstakingly built by hand on site, that requires a completely new way of thinking. It's a shift from seeing construction as a craft to seeing it as a manufacturing process. So as our design software gets smarter and project timelines get even tighter, this whole Lego-like approach is going to stop being the exception and start becoming the rule. We aren't just watching a new building technique take off, we are literally watching the industrialization of construction happen in real time.